New Thinking Aloud is presented by the California Institute for Human Science, Mind, Body, Spirit University, a leader in fully accredited in-person and online U.S. college degree programs in the topics we cover here. Visit their website at cihs.edu.
Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. Today we'll be exploring time and free will. With me is Dr. Ruth Kastner, who is a physicist and a philosopher specializing in the foundations of physics. She is on the faculty at the State University of New York in Albany and is also a research associate at the University of Maryland in College Park. She is the author of The Transactional Interpretation of Quantum Mechanics, The Reality of Possibility, and is also author of Understanding Unseen Reality, Solving Quantum Riddles. Welcome, Ruth.
Thanks very much. It's great to be here.
Free will is a fascinating topic to me because traditionally speaking, certainly in classical physics, the idea of teleology or purpose or something associated with free will is considered an impossibility. Everything is determined.
Right. Well, classical physics has deterministic laws, as you said. And the idea of attributing a purpose to something, or the way Aristotle did, is not really considered a legitimate part of modern science. It's all, you're supposed to use, mathematical formalisms to explain the phenomena that you see. And classically, all those formalisms were deterministic in that all you have to do is put in some initial condition, apply your law, and then you can say where everything's going to end up at any arbitrary point in the future.
Mm-hmm. Of course, that totally contradicts our normal intuitions.
Right. That's one of the puzzles in physics and philosophy of physics. There's a lot of tension between what seem to be deterministic laws, or in quantum theory, you've got some probabilities, but people still feel that at the macroscopic large scale level of applying those laws, we still effectively have some kind of a deterministic situation. So why is it that we think we have free will? Why is it that we think that an experimenter, say, can choose which kind of measurement to make? Mm-hmm. So it's a big puzzle.
Well, I can say this, that not every branch of science rejects the idea of free will. In the behavioral sciences, I think there's some room for it. And back in the days when I was studying at the University of California, my dissertation, one of my advisors, C. West Churchman from the School of Management, emphasized the fact that management science definitely recognizes free will.
Ah, interesting.
Mm-hmm.
Well, yes, certainly the fields of psychology
mm-hmm.
and also neuroscience, I think, are very much concerned with looking at what's going on in the brain when people are making choices and so on. So there is a lot of tension there, and I happen to think we really do have free will, that it's not just a delusion on
mm-hmm.
our part.
Well, then the question is, within a strict scientific model, how do you accommodate that?
Well, the first thing is you look at quantum theory, and my understanding and my proposed interpretation of quantum theory is that it is genuinely indeterministic. So, in other words, at a fundamental level, when you have a quantum system that's created, it really is fundamentally indeterministic as to what's going to happen to that
mm-hmm.
system in the future. So I reject determinism at that level.
In other words, God does play dice with the universe.
Well, in a sense, you could say that. And of course, we know that Einstein didn't like that. But I guess if you want to put a positive spin on that, you can say God gave us free will, perhaps. Mm-hmm. And he said, well, okay, I'm not playing dice. I'm saying you guys make use of your freedom and choose wisely. And of course, as a foundations of physics person, I don't get into moral philosophy and I don't advocate any particular spiritual view or anything like that. But it seems reasonable to suppose that that's where legitimate free will can enter.
So you're saying that indeterminism or probability opens the door for free will.
Right.
What seems indeterminate from the outside might be free will from the inside.
Right. And of course, in my particular interpretation, I don't have any concrete model of how free will works. But I argue that it is fundamentally indeterministic. And so, since I'm a proponent of the transactional interpretation, what I propose is that when you have a quantum system emitted, which is called an offer wave in the transactional picture, and you also have absorption being taken into account. In other words, you have potential absorbers that can receive whatever it is that's emitted, that quantum system, that they are also participating and they respond with these confirmations. And it's at that point where there's a kind of behind the scenes negotiation where it is definitely not determined where your emitted system is going to end up. In other words, if it's a photon, which of these absorbing atoms will actually win the competition and gain that photon? And it's at that level that we might say, if mind is something that operates at the quantum level, then mind could have some interplay with this behind the scenes negotiation and if you will sort of break the symmetry of all these possibilities and say, okay, I'm choosing this one.
So you're open to the idea that the photon itself might be exercising free will.
Well, that's a possibility too, and I'm certainly not the first. I think there were perhaps Pauli, some of the original quantum theorists noted this interesting. Heisenberg himself almost said it's almost as if the photon or whatever system we're talking about is making its choice, for instance, and a photon deciding whether or not to go through a polarizer, making a choice when it gets to that polarizer. So we might suppose that quantum systems have some very primitive degree of consciousness or choice, and it's reasonable to suppose that organisms, that more complicated organisms, might have a higher level, more highly developed ability to make those kinds of choices.
Now, I think what you're describing is known in philosophy as panpsychism.
That's right. We could say that that's a form of panpsychism, that the ability of having conscious perception is something that applies across the board, although certainly in varying degrees. I mean, we would never say a photon is, going to decide whether to start a war or what political party to vote for or anything, but just at this very rudimentary level, perhaps, there's some choice going on.
Well, and some awareness as well, presumably.
Right. Yes.
One can't exercise choice without awareness.
One would think so, yes. Yes.
So that suggests, it's one way to resolve what some philosophers have called the hard problem with regard to the mind-body problem. How is it possible that inert matter could ever be conscious? And the answer being it was never completely non-conscious to begin with.
Yes, that would be one way to completely evade the hard problem. Because, of course, the hard problem is to account for how consciousness emerges in some substance that's inherently non-conscious.
Right.
And so if you allow that at a very fundamental level, this would be a form of monism, of one substance view, that if the basic substance is inherently, intrinsically conscious, then certainly if you've got more, then it could be self-organizing, perhaps, if it's exercising free will. And of course, my proposed interpretation of quantum mechanics doesn't make any claim about those things, but that's certainly a possible ontology.
You're open to that.
Oh, certainly. Yeah. It's certainly compatible with my interpretation.
So maybe more than open, you're leaning in that direction.
Personally, I think that's the likeliest case. I could be persuaded otherwise, but it certainly seems the simplest thing. I mean, why have dualism if you can get whatever we need from a single substance?
Sure. Makes perfect sense. Now, how does time fit into this notion of free will?
Well, time comes into the puzzle because traditionally, and at least in modern science, in view of relativity theory especially, a lot of physicists have this what's called a block world picture. And a lot of physicists think that in view of relativity, you must have the past, the future, the present doesn't really mean anything distinct from either one. In other words, there's no real meaning to past, present, and future. These are all relative, and that what actually exists, according to this view, is just a big block of space and time. From the Big Bang, from t equals 0 to the end of the universe, and it's all there.
From alpha to omega.
Right. And all the events are there. And I dispute that. I think there are good reasons why, in fact, that's not obligated, that we are not obligated to adopt that ontology.
So that would be a deterministic viewpoint, wouldn't it?
Right, and in a way it's almost what's called super deterministic, because not only is your future sort of destined, it already exists, it's already there, and you're sort of just riding your little world tube, as you will, down toward your inevitable fate that exists already in the block world.
And what you're telling me is that most physicists subscribe to that view.
That's my understanding, yes. I mean, that there is a block world. And in fact, many quantum people who do foundations of physics and who have proposed interpretations of quantum theory also have proposed interpretations in which you have to have a block world in order to solve various quantum puzzles that they're trying to address. And these are mainly the hidden variable models. Yeah. But so my challenge to those folks is, well, if everything's in the world already, then when you talk about free will, you can't really mean something that's up to me. In other words, if you've got like a stack of dominoes and they're all set up and you knock over the first one, it's not up to any of those dominoes whether they're going to fall.
Right.
Now, if they want to call that free will, then they're using the term in a way that I think is kind of vacuous.
So those who accept the block universe model basically are saying that it has been predetermined that we humans live with the illusion that we have free will.
Well, people, I think if they want to be consistent, they say that. There are actually those who say, no, we have free will because we don't know what's going to happen. And I've argued that, well, that's not any good. Yeah. Just being ignorant of what your future is doesn't mean it's up to you what you're going to do in the future. So that's one of the issues here that I've been contesting is, okay, those who say, okay, there's a block world, our sense that we have free will is a delusion. Well, at least that's consistent. I disagree, but at least they're consistent. But there are a lot of people who kind of want to have it both ways, and they want to say, oh, future experimenter can decide whatever experiment they want to make. But if, according to their ontology, the event of that experimenter making a measurement is in the block world. So it's not up to that experimenter at some earlier time what he's going to do at that point.
Right.
That decision has been made.
So in other words, the future is predetermined all the way to the end of time.
Right. In a block world, all the events exist and end of story. Yeah. So there are no choices in terms of an agent. The other problem with that account is that it assumes that we as observers are somehow moving through this block world where that isn't explained at all.
Yeah, like a phonograph record being played.
Right. Where did that come from? So that's like our experience of the passage of time is seen as simply a perspectival, sort of our perspective because we're moving through, but then they have to kind of take that as just an assumption that we're moving through the block.
And from that point of view, the past hasn't really disappeared. It's still there somewhere.
Right. The past, the present, the future, they're all equally concrete events.
Now, I'm reminded of a statement Einstein once made. I gather he might have been a subscriber to the block world.
Yes.
He wrote a letter of consolation to the widow of one of his fellow physicists, and he said, your husband and I are two of the few people who would really understand that he really exists. He hasn't actually died, that the past is still real in some sense, so your husband hasn't really gone.
Well, that's what they call the B series of time, to use a technical term, that all the events exist in the same way. I mean, and, I happen to disagree with that, and a lot of other people
How do
too.
you view it?
I think that what exists is the eternal present, and that Events do occur, but they occur out of this transactional process, which I discuss in my books and we've discussed elsewhere.
Yes, influences from past and future.
Right, and from possibilities that are not in the space-time realm, that are in the realm of possibility, but that are real and that actually do interact and give rise to concrete events. And when we have what I call an actualized transaction, that establishes the emission of a quantum system from one thing to another. And in that sense, you have a piece of space-time emerges. As from our own perspective as conscious agents, we are collections of absorbers. So we are participating in this process of the emergence of space-time. And the way we experience it is that past events are kind of falling away from us, but we are always in the present. And I think if we check our own experience, we can corroborate. We always exist in the present. We are always existing in the present, and we experience the past falling away from us. We don't experience the future. We can remember the past, but only sort of indirectly. So I think of it as there's like a snake casting off its skin, if you will. The living snake is in the present, and that's where we exist. Yeah. And our sense of time is really the perception of change. What is time but energy being taken from one object and given to another, and we perceive those experiences of change.
In other words, if there were never any changes, if everything were static, nothing ever moved,
right,
there would be no time.
I think so. I think so. I mean, I think time is really the way we describe change. We experience change, right? We don't really experience time. I mean, how do we look at our watch, which my watch is broken, so I'm not wearing it. But how do we measure time? We see something moving.
Right.
We see change. You perceive change. You perceive change through the exchange of energy from one thing to another.
Well, I have to ask you about one of the great mysteries of time to me is in Einstein's relativity theory. If a human could travel on at the speed of light, with like a photon does,
right,
and looked at his watch, it wouldn't move. There would be no change. Time stops. But for other people, this human could travel to the end of the universe and back and come, and for people, let's say on Earth, billions of years would have passed.
Right.
But for the traveler at the speed of light, no time at all would have passed.
Yeah, isn't that wonderful? And that was one of the earliest thoughts that helped Einstein develop his theory. And the trick there is that the photon has no mass, has no rest mass. Anything with rest mass cannot travel at the speed of light. So you have to be massless to travel at the speed of light. And it is true that a photon does not experience any change. It's only those of us, if you will, systems that have mass that can participate, that can serve as emitters and absorbers of photons. And in that way, we experience change.
But
and that's time.
Even one of us with mass, we all have mass.
Right.
As we approach the speed of light, time slows down, does it not?
Our measure of time will slow down. That's right.
So that you would still have the same paradox.
Yes, you still have that same weird relativity that really boils down to our measures of time are really conducted through energy exchanges. And so what's happening as we are moving at a greater speed relative to something else is the way that energy is transferred is going to change as described by relativity. And it's those transfers, as say there will be fewer transfers for us than maybe for someone else.
So it's really true, experimentally confirmed, I believe, that in the future, if we have space travel that gets close to the speed of light, astronauts may journey throughout the universe and come back and will have aged very little relative to people on Earth.
Absolutely, that's true. That's a real effect. And technically it has to do with the fact that they undergo accelerations as well. So you need to that's the whole twin paradox, is acceleration has to be part of it.
Yeah.
It's because they have to come back that you were able to measure that difference in ages.
Right.
Otherwise you would never see any difference.
You wouldn't notice it.
That's right. You would never be able to find any difference. Yeah.
How interesting. Well, how does that relate to free will, if at all?
Well, the thing that is related to free will here is really the idea that the future is open. So if you have a block world, then as we talked about before, if you want to talk about free will, then you're really just trying to have it both ways. You're trying to say, well, when I use the word free will, I just mean that I don't know what my decision is going to be in the future. But in order to have genuine free will in the sense that it's up to me what I do at some point in the future, then I have to allow that the future events are not actualized yet. And that's what my particular proposal is about.
In other words, what you're telling me is that the existence of free will is really incompatible with the block world.
Yes, I think so. I think unless you want to change what you mean by free will, and to the point where I think it's vacuous. Yeah, you can't really have it both ways. Yeah.
Well, I'm going to guess that there's some other interpretations that might accommodate both, like the many worlds model of quantum physics. I don't see that it's really helping with free will either, because in that picture there are many different worlds in which you make every possible decision. Yeah. So in what sense did you make this decision of your own free will? You made all possible decisions. Which one are you really? And, so I don't think that... But just as I'm always in the now moment, I'm always here.
Right.
Some other Jeffrey is in another universe with a different decision.
Right. And what does it mean? Then you have to kind of get into this whole identity problem where what does it mean for you, Jeffrey, to be here and not on Mars doing something else in a different universe? And in what sense did you make this decision as opposed to the other one if you actually made all of them? So that's another thing that they would have to deal with.
Ultimately, we're going to come down to various philosophical conundrums. Yeah. Sooner or later, one way or another. It strikes me that probably a lot of physicists who accept the block world, and as you say, that's most of them, probably go through their daily lives accepting that they do have free will. And in fact, our legal system more or less demands it. Right.
And they look both ways before they cross the street, and they decide what to have for dinner. But I mean, if you were to challenge them and say, how does this square with your theory? Many of them will say, well, yeah, I admit that I don't really have free will. And I know physicists who say that. Yeah. Then others will say, yeah, I have free will because I don't know what decision I'm going to make. And my response to them as well. The domino that's going to fall when you push the first domino over also doesn't realize it's going to fall, but it's not up to him, If it's not up to you, then what do you're trying to have it both ways, basically.
So quantum physics, being basically indeterminate, what doesn't really lend itself well to the block world, I would think.
Right. I mean, you only get a block world in quantum theory if you put in hidden variables or things like that to try to get an interpretation that gets around certain things, that you try to get around non-locality and things like that. Then you end up with a block world picture, and then you end up with, having to explain why you think you have free will.
So that's, which is what we've referred to earlier as the standard interpretation.
Well, the standard interpretation, would be probably, it depends who you ask. Some people might say, yes, that involves a block world. Others might not. I think Niels Bohr would have said, yeah, there's a block world. But he would have arrived at that later in his life, because he actually underwent an evolution in his thinking. So it depends.
But what you're maintaining is that physicists who insist on the block world and therefore deny free will are constraining themselves unnecessarily, that quantum physics as you interpret it does not require that.
Right. I don't think it requires a block world, and I also think that relativity doesn't require a block world. That's one thing where many physicists think that it does because of the structure of the theory, getting Lorentz invariance and so on. But there are other physicists who have shown that in fact you don't have to have a block world ontology to be consistent with relativity.
Now, the block world, as you describe it, reminds me of what I understand of the philosophy of Baruch Spinoza. He was a complete determinist, I believe, and seemed to feel that the being willing to accept that we have no free will, I think for him meant that everything is constrained by the will of God, and if we can accept that, we enter into some sort of a state of enlightenment.
Yeah, that almost kind of sounds a little bit like Stoicism in a way, and that's an understandable view for people who didn't know about quantum mechanics, and it was very, very reasonable to think that if there are mathematical regularities and laws that describe the world, and if God set those up and he's all-knowing, then obviously he must know everything that's going to happen to you and it's all decreed and so on. So that's been a dilemma for millennia to reconcile our sense that we have free will with seeming laws that deny that. But my position is we don't need to think that our physical laws actually are in conflict with free will.
Well, that's a very strong statement, actually.
What I'm trying to counter is overly strong claims that physics requires a block world, because strictly speaking, that's wrong. So, I mean, my point is simply that it is not true that physical law demands a block world.
An important point. I mean, because you're getting at the heart of an argument about the nature of reality itself.
Sure, and of course it has very important implications for our sense of personal responsibility, and it's a big deal to know whether or not you're deluded that you have free will.
Well, in effect, what you're doing is you're taking quantum physics and making it compatible with behavioral science, with management science, and legal theory.
Yeah, and I mean, those things can be compatible. They don't need to be in tension. What creates the tension is the unnecessary assumption that physical laws demand a block world when they really don't.
Ruth Kastner, thank you so much for this discussion. It's been fascinating.
Thank you. It's been a pleasure.
And thank you for being with us.
Book 3 in the new Thinking Aloud dialogue series is UFOs and UAP, Are We Really Alone? Now available on Amazon.
You can now download a free PDF copy of issue 7 of the New Thinking Aloud magazine or order a beautiful printed copy.